is similar triangles. Triangles that look the same, like this one here, but they have different sizes. Okay, so they must have angles, all angles equal, but the sides don't have to be equal. They just have to be in proportion. Okay, so there are 4 tests. In fact, we can't really use this abbreviation, but this just helps us to remember these tests. It's very similar to congruent triangle, except that when you write down a reason, you cannot put SSS. You have to write this full sentence for the reason, for similarity. Yes, or you can abbreviate a bit, but you can't use this abbreviation. You have to write down a description of the proof. Let's write down. Yep, 3 sides are proportional. Yep, you can do that. Okay, let's start with the first one. Prove the following triangles are similar. Have I started recording? Yep, I have. Okay, good. So what you do is, let's look at the ratio of sides. So you get AB matched with PQ, 6/3 equal to 2. So one side is double the other side. And then you do AC over PR, also double the other one. And then do BC over QR, also double the other one. So you have to show they're all the same. So you say, therefore, triangle ABC is similar to, note the symbol for similar to, it's 3 vertical lines instead of horizontal lines for congruence. So 3 vertical lines, just think about parallel lines, is similar to triangle PQR. And the reason you write is, what do you write? You write 3 sides are in proportion. Yeah, something like that. You can't say SSS. SSS means all 3 sides equal. This means all 3 sides in proportion. And there's no abbreviation for that, just write like that. 3 sides are in proportion. Good. Any question? And then we'll do more. Let's do the next one. Again, there are 2 sides given, and the included angle are equal. So you will start saying this. So you do BC over QR equal to 3/2, and BA over QP equal to 9/6, which is simplified to be also 3/2. So they're the same, isn't it? And then you say angle CBA is equal to angle RQP given. So you got 2 sides in proportion, and the included angles are equal. These are called included angle, the angle in between the 2 given sides. So you say, therefore, triangle ABC is similar to triangle PQR. And the reason you give is 2 sides are in proportion, and the included angle are equal. Okay, like that. So it's either all 3 sides in proportion or 2 sides in proportion with an included angle equal. Yep. Come in. Continuing, so we did this example together. 2 sides in proportion, included angle equal, or 3 sides in proportion. Okay, we're on page 9 at the moment. In a minute, we're going to move on to page 10, which we're going to look at the other 2 similarity tests. Next page. Okay, 2 more tests. The next one is the most common one used in the exam, and it's also the easiest one. You just have to prove 2 pairs of angle equal. Because why do you have to prove 2, not 3? Because the third one has to be equal by angle sum of triangle, right? So you only have to prove 2 pairs equal, then all the angles are equal. So let's start with this. So you say angle ABC equal to angle PQR given. And then you say angle ACB equal to angle PRQ also given. And what do you do? Then you say, therefore, they are similar. So you only need 2, not 3. You can do 3 if you want, but it's not necessary. 2 will be sufficient. And the reason is the shortest one out of the 4 is called equiangular. Means all the angles are equal. And fortunately, in the exam, most of the question will just require this test. This test is used most often, equiangular. And the last one's not very common, but let's go through that. Last one's a little bit like RHS. Okay. But that one's pretty short. Okay, done? Okay, let's look at the last one. Last one, what you have to do is you have to do the ratio of sides. So AB over PQ. In this case, 6 over 8, which is 3 over 4. Also PQ, also AC over. Work? Okay, try again. AC over PQ equal to, not PQ, PR. PR, okay, over PR is 9 over 12, which simplifies to be 3 over 4 as well. And then you have to say they are both right angle ABC equal to angle PQR equal to 90. They are both right angle given. So what do you conclude? You say, let me have a look at how they write it. The hypotenuse and one side of a right angle triangle are respectively proportional to the hypotenuse and one side of the other triangle. Maybe we can abbreviate that. Maybe we'll just copy it. Maybe easier. Too hard to abbreviate, so you just write. But you just have to write down what you saw. So just write down the description. The hypotenuse. I don't think this one used a lot, so not to worry. The hypotenuse and one side of a right angle. It has to be a right angle triangle. Are respectively proportional to the hypotenuse and one side, side of, you can say maybe proportional of another triangle, right angle triangle. Done. Okay. That's very long. I agree. You can't. There's only side means sides are equal. You can't because side means sides are equal. They are sides in proportion. RHS means a right angle, hypotenuse equal, side equal. Because that's already used for congruence. You can't use the same thing for similarity. No, you can't because it's a different thing. Because the abbreviation SSS means sides equal. They are not equal. They are in proportion. No, you can't. No, you can't. Hypotenuse on one side are proportional. Or okay, good. Let's move on. Now we'll do some simple questions. Yeah. Yeah, you have to abbreviate in a clear way. You have to make sure they understand, yeah. That's okay, yeah. But this one's a little bit hard to abbreviate. I don't know how I could abbreviate it to make it clear. Yeah. Yeah, because you're really specifically pointing at hypotenuse. Oops, wrong one. Hypotenuse, so you have to specifically mention this, and one side are proportional to the other hypotenuse. And Yeah, to the other triangle, also to the hypotenuse and one side. So hypotenuse has to be proportional to the hypotenuse, side has to be proportional to the side.
Can't you just say that the hypotenuse is out of proportion?
Maybe. Right angle triangle. Okay, let's move on. Okay, let's look at the next one. Let's do some examples. So once two triangles are proven to be similar, all the matching sides are in the same ratio, all the matching angles are the same. Okay? Right. Prove the following pair of triangles are similar and then find the value of the polynomial. So your first step is to, now since all three sides are given, let's find the ratio of all three sides. So you start with AB match with, now AB is the second longest, you match with the second longest, right? So AB match with FD, which is 12 over 24, so that's half. And then you pick the shortest one match with the other shortest one, AC over 10 over FE, also equal to 5 over 10, which is half. And the last bit, BC, which is the longest one, match with the longest one, 13 over 26, also half. Yep. So prove they're all half, they're all the same, so you can write down a conclusion. Therefore, I could say, therefore, triangle ABC is similar to triangle DEF. And give a reason. The reason is all three sides are in proportion. In proportion. Proportion. Alright, this one's not too bad because they have to write a lot. So just say all three sides are in proportion, but that takes long to prove because you have to divide all the sides. Okay, once we prove they're similar, we can find the matching angles. So, which one's matching with which? So can you see 67 opposite to the 12? Now, which side does 12 match? 12 match with the 24, isn't it? So you find the angle opposite to the 24, and they are the matching angle. So you say, therefore, theta equal to 67 degrees, matching, you have to give a reason, matching angles in similar triangles. Yeah, I just noticed. I see about to drive towards me. I just noticed. Okay. Okay. Okay, all right. All right, let's move on. Any question? Let's try to do the next one. All finished? Okay. All ready? Okay, let's move on. Next question. Two angles are given, so they're pretty easy. So you just say angle CAB equal to angle FDE equal to 30 degrees given. And do the same thing, angle CBA equal to angle FED 55 also given. And then you say, therefore, triangle ABC is similar to triangle DEF, equiangular. So that one's the quickest. So two angles and write equiangular. Means all angles are equal. And then you find the missing sides. Now, how do we find the missing sides? We do the ratio of matching sides are equal. So you say x match with 6 equal to 8 match with 10. Give a reason. Matching sides in similar triangles. So the matching sides in similar triangles are in proportion in similar triangles. You don't have to say are in proportion. Just say matching sides in similar triangles. So we'll know that you use that rule. And to find out x, all you have to do is just multiply both sides by 6. like we solve the equation, like that. So therefore, x equal to 2 point, what do you say? 4.8? Okay, 4.8. Yeah, 4.8. Good. Done. Right, we've got another 3 to go through. So similarity are a little bit harder than congruence in some way, because you have to do a lot more things. Try the next one, see what which similarity test you can identify to prove that they are similar. Start up with something you know, and then try to find out the other thing you don't know using geometry. Okay, good. So prove the 2 triangles are similar. Notice that there are sides given. Let's find the ratio of these matching sides first. See what we get. So we're going to start with, so you do part A, Zx. See, Zx is the long one, match with the 3, match with xw, 12 over 3, which is 4, and then do the other bit, xy over xv, 8 over 2, also 4. Now, we can't do the third side because there's no information, so we just leave it as 2 sides. So we've got 2 sides in proportion. So what else do we have to do after we've got 2 sides in proportion? Angles, yeah, because we are thinking about the SAS one. So which 2 will be equal? Yeah, these 2, right? They're vertically opposite. So you write angle ZXY equal to angle VXW, vertically opposite. Yeah, like that. Vertically opposite ZXY, VXW. And these 2 we should actually say given. We forgot to do that. Given. So each statement followed by a reason. Yeah, we're ready. So we just say, therefore, the 2 triangles are similar. So therefore, triangle, just copy down the statement. ZXY is similar to triangle X VXW. What do you say? 2 sides. This one's a little bit longer. 2 sides are in proportion. 2 sides are in proportion, and the included angles are equal. You have to use the keyword included. You can't just say, and the angles are equal. You have to say, and the included angles are equal. Because only the included angles being equal for them to be similar. If that was a different angle, not included, then you can't use that test. Okay, now we can find out the size of theta. Let's work out theta. Now, theta matches with 3, and 3 matches with 12, isn't it? And 12 matches with 86, right? So therefore, the matching angle must be opposite to the matching sides. So therefore, you say theta is 86, matching angles in similar triangles. Okay, matching angles in similar triangles. Yeah, you just say that. Yeah, you don't have to really explain how you know that. You just write this equal to that, matching angles in similar triangles. Yep. Okay, then we'll do one more part, C. We've been doing that a lot. How do I prove 2 lines are parallel? So let's look at which 2 lines. So we've got this one and that one. How do I know if they're parallel? There are some tests we can do. Which test do we use? Yep. There's 3. So we're going to use the, now we've just proven these 2 are equal, right? They are both 86 degrees. What sort of angle do they form, these 2? Alternate. So you say, since angle ZYX equal to angle WVX, proven in part B, they're equal. Therefore, you say VW is parallel to ZY. because the alternate angles are equal. Alternate angles are equal. Okay, good. And there's another one for you to try to prove they're similar before you find the missing sides. Have a try. And then there's one more. Okay, hopefully all done. Try the next example, 24. Okay, think about what similarity test you can use before you start to prove things. So start with something that you know, and then you only need 3. Okay, all right, let's move on. So it's all done. Okay, good. Let's move on. Okay, good. So example 24. Now, if you look at this, the two triangles, so ABC is this small one, which you can draw here, and then you got the big one. So you try to prove that ABC is similar to ADE. Now, if you draw them separately, you got 1.5 here, x there, y here. This one will be, you have to add 1.5 plus 0.9 first, which is 2.4. The other one is x plus 1.3, 3.6. Now, obviously, you can't do the ratio matching sides because a lot of sides are not given, isn't it? And you can't use the SAS one. You need 2 sides and the included angle equal. There's no 2 sides we can use to prove they are similar. So that let's leave up with the last 2. It's not right angle, so we can't use the RHS one. So there's only leave us one, equiangular. So which angles are equal? We'll start with the obvious one. Yep, ABC, and what reason is that? Yep, these 2 are equal, corresponding, so you just say angle ABC is equal to angle ADE, corresponding angles on parallel lines. You have to include the word on parallel lines because we're using the fact they are parallel. Then you can say the corresponding angles are equal. Mention which lines you're referring to. BC is parallel to DE, so we know exactly where you got it from. Corresponding angles on parallel lines. BC is parallel to DE. Okay, we need one more angle, then we can say they're equiangular. Which 2 angles are equal? Yes, I prefer to use common because it's quicker to write. I don't have to write a long thing. So I just write angle BAC is equal to angle DAE, common angle. You can use prove the other one equal as well, but this one's shorter. And you only need 2 angles. You don't need all 3. Then you write common angle. All right, good. Therefore, you say triangle ABC is similar to triangle ADE, equiangular. So that's more like a typical exam type question, equiangular. And then they're going to force you to find some missing sides. That's why this is a common question, because once you do that, they just get you to find sides. Okay, how do we find the sides? I've already drawn the 2 triangles separately. So let's find the ratio matching sides. We're going to find y first because y is easier to work out. Now, notice that y will match this side, right, because it's opposite to the same angle. And then we're going to use these 2 sides as the matching sides. Let's do that. So in part B, y over 3.6. Notice that y comes from the first triangle. You also have to put 1.5 on the numerator for the other side. 1.5 over 2.4. Reason? Matching sides in similar triangles. In similar triangle. Okay, good. So you do that. And then you solve. And how to solve? Very easy. Just multiply both sides by 3.6. And you can use your calculator to do that. Calculator, so you get 1.5 in fraction 1.5 over 2.4 and then times by 3.6 equal 2.25. Exactly, good. Y equal to 2.25. Finish. That's for Y. See if you can work out what X is. X is a little bit harder to find because the equation is a little bit harder to solve, but you write down the same thing except you use X instead of Y. Have a try. Yeah, you do that, yeah. So you do this, match with the other one. So if you use the X, this will match this side. And then you just use this again, right? You write equation. The equation just be a bit harder to solve. So you do part C. So how do you write the equation? X will match with X plus 1.5, 1.3. So these two sides are matching. And then do 1.5 over 2.4 again. 1.5 over 2.4. Now this time you have to do more work because there's two x's you have to deal with. So what you do is you still have to get rid of the denominator. So multiply both sides by 2.4. 2.4, that will get rid of this. So you get 2.4x over x plus 1.3. And then what you need to do is get rid of the other denominator by multiplying by x plus 1.3 on both sides. And then that can cancel, which is equal to 2.4x equal to 1.5x plus 1.3. And to solve it, you expand, collect like terms. Okay, have a try. Alright, so you expand, so you get 1.5x plus 1.5 times 1.3 is, anyone? I have to try. 1.95, okay, 1.95. And then what you need to do, just subtract both sides by 1.5x. Subtract by 1.5x, that cancels this. So that would be 0.9, isn't it? Equals to 1.95. And then what do? You're going to divide by 0.9. Would it work? Hopefully. 1.95 divided by 0.9. Yeah, maybe I think you will get maybe you get decimal point. Let's see. 1.95 divided by 0.9. You can leave fractions. Exact form. 2 and 1/6. 2, 1/6. Try not to round if possible. That's the length of x. Yep. Okay, in that case you do 2.17. Okay, so you write down, I forgot to write, matching sides of similar triangles. Matching sides in similar triangles. So let me see. Good. So we've got one more question to go through, then you can start the work. All right, example 25. Example 25. Okay, think about this. This one different from the other one. There's no parallel lines, right? So you can't use that. So let's draw them separately first. Let's draw the first one. D, E, A, 1.2, 0.8, 1.7. And the other one, the big one, M, that will be 2, that will be 3, right? If you add 0.8 by 2.2, you get 3. This is 1.2 plus, let me write it in bracket, 1.2 plus 0.8. The other one is 0.8 plus 2.2. Okay, so we got these information. So when two triangles overlap, you can draw them separately. And you can clearly see what method we should use. So what should we do now? There are two sides given, right? There's two sides, so maybe we can do the ratio matching sides first. But which side will match with AD? AC or AB? Which side will match with AD? AB, why? Because it's the longest one. Yeah, be careful. You match this with this. Whereas the other one, we match the 1.2 with the same side. But in this one, it seems that the triangle has been changed. So you match the big with big, small with small. Okay, so AD over AB equals to 1.2 over 3, which you can simplify to be 0.4. And hopefully that the other one also gives you 0.4. So you use your calculator for the second one. So you do AE over AC is 0.8 over 2. Or also 0.4. Alright, so we've got two matching sides in proportion. And we need to include an angle. Which angles are equal? A, that's common, isn't it? Very nice. So we say angle DAE is equal to angle CAB, common angle. Now we prove they're similar. Okay, so we're going to say, write a conclusion. Therefore, you just have to copy down the question. Triangle AED is similar to triangle ABC, not equiangular. Two sides in proportion and the included angles are equal. So write two sides are in proportion, and the included angles are equal. Included angles are equal. Alright, prove they're similar. Then we can find the value of M. And that one's not very difficult. Just set up an equation, you'll be able to work out what M is. And just have to find the matching sides. Okay, good. So what we do is this. Let's try to do it. So we're going to find M. M match with 1.7, isn't it? Right? So you say M over 1.7 equal, and find another matching side. So you do 3 match with 1.2. So you write equal to 3 match with 1.2, and then you can solve for M. Multiply both sides by 1.7, and then you can find M correct to maybe 1, doesn't say, 2 decimal place. So write M equal, use a calculator, 0.4. This, okay. I think, so you do 3 over 1.2 times by 1.7. Oh, exactly. You don't need to round, just 4.25. Done. And then you say matching sides in similar triangles. Sides in similar triangles. Triangles. Yeah, like that. Any questions? Right, we'll just do one question from challenge, then we're done. Just one question. And then you can start the work. You only have to do 10 questions today, question 1 to 10. And in the remaining 40 minutes, let's do that. Okay, just one more question. Just question 1, and then we're done. I know it's getting a bit boring, but if it's, well, not exact, yeah. All right, just, yeah, maybe it's 6.5, yeah. We want to do this because we haven't used the fourth similarity test. I want to do it with this one, so you know how it works. Okay, let's do one. Quiet, please. Just one. One. Okay. Okay. C, B, D. 12, 9, 12, 20. Okay, draw this first. Okay. All right, now. So these two triangles, we try to prove they're similar. So in this case, we can't use the included angles because there's no included angles. So it's likely we're going to use the ratio of the hypotenuse is equal to the ratio of the other one side of the right angle triangle. So what we do is we're going to do the matching. So obviously the hypotenuse match with the hypotenuse. So you do AD over DC equal to 20 over 15, which is 4 over 3. Now the next question is, which one match with 12? But you get 12 over 12, which is 1. They're not equal in ratio. So it can't be 12 and 12, isn't it? Because otherwise they get the same. Well, you have to match 12 not with itself, with another one. You have to choose something different. Because they're similar, the ratio are equal. They are not meant to be equal. They are not meant to be the same. They're not congruent. Get the idea? So you're not meant to use dB over dB. You do dB over BC. 12 over 9, also 4 over 3. Get it? So you don't use the same one because you end up getting 1. They end up being equal. They're not supposed to be equal in similar triangle. Right? And then you say, angle ABC is equal to angle DBC. They're both 90 degrees. Right? And then you say, therefore, they're similar to triangle BCD. And then you say, ratio of hypotenuse and one shorter side and one side of a right angled triangle is proportional to the hypotenuse and one side of the other right angled triangle. Done. You don't need to find matching sides. Yeah. So if you write it fast, it's still fast. So you don't need to worry about long. Long becomes short. Okay, good. All right, so we're going to stop the video. Okay, good. Thank you.